Welcome back, my friends. In this video, we will be talking about algebra. This video is specifically for the beginners who are new to algebra. So starting with some definition, algebra is a branch of math which deals with symbols and not only numbers but symbols and numbers, and the how they are the operation between these symbols or the arithmetic operation across them. So first thing we have to define is the variable versus constants. So most of the time, like in basic math, we deal with only numbers which are constant, like let's say 1, 2, radical 10, 5. These are called constants because the value is constant, it never changes. But for some other in daily life, there are so many things or variable, like there are so many things that the value are changing. So let's say if we are talking about the blood pressure of a person, the blood pressure, it's always fluctuating, it's going up and down, so it's variable. So if I show the blood pressure with a symbol which is called, let's say, X, it shows that the value it's changing, it's not constant, so it varies. And I show it with a symbol which is variable. So let's say here 6x minus 4 it's equal to 32. This is an example of algebraic expression. So the constant number in front of the letter is called the coefficient. So the number in front of the variable or the letter is called the coefficient. The letter, it's variable because the value is constantly, it's changing, it's not constant. The value could be at some point 1, at another point could be 2, 3, or whatever. And then negative 4, so you see that here we're doing an operation on the 6x, and then the value is equal to 32. So here you can see that 4 and 32 are constant values. The 4, it's always 4, it never changes. And 32 is also a constant. So the constant could be positive or negative, it doesn't matter. Okay, the next terminology you have to learn when you're doing algebra is term. Okay, so 5x is a term. A term is always a combination of letters or numbers. Okay, so it could be a combination of numbers and letters, or let's say only a number. So here the 5 is a coefficient, the x is a variable, but the whole thing is called a term. Okay, so another terminology would be like terms. The like terms is when the two terms have got the same variable, the same letter, okay, and then the exponent or the power of the letters are also the same. Okay, so not only they have the same letter, but the power of the letter is also the same, but the coefficient could be different values. So these two terms, 3x squared and negative x squared, so the letters, both of them, the letter is x and the exponent of both is 2. So I could say this one and this one are like terms. Okay, so once more, for like terms, not only the letter but also the exponent should be the same. Another example would be 5x and 2x. So the letters are the same, the value of the exponent or the power is also the same, but the coefficient or the number in front, it's not the same. Another example would be 6x cubed and 0.5x cubed. So the letter, the power are the same, but the number in front, which is the coefficient, it's not the same. They are called like terms. in algebra, when you want to add or subtract terms, you are only allowed to add or subtract like terms. Okay, so first of all, you have to find the like terms, and then you start by adding or subtracting the like terms. But how? Let's say if I want to add these two terms because they are like terms, only I write the letter with the exponent, and only the exponent will be added, or the coefficient would be added or subtracted. So let's say here, if I want to add these two, okay, so the x to the power 2 is written down, but the coefficient 3 plus negative 1, which is 2. Another example, 5x plus 2x. So the letter is written down, the exponent it's 1, it doesn't change. 5 and 2 are 7. So you can see the letter and the power of the letter doesn't change, but the coefficients are either added or subtracted. Another example, 6 plus 0.5, which would be equal to 6.5 or 13 over 2, 6.5. And then x, which is the letter, and the exponent, x cubed, just stays the same. So let's continue talking more about addition and subtraction. As I just mentioned, only like terms can be added or subtracted. So here I usually use an analogy. Let's see, this is a fruit basket. Sorry, I'm not very good at drawing. So the orange circles are oranges and the green ones are green apples. So if someone asks you how many apples or oranges are in the basket, you do not combine the apples and oranges together because they are different objects or different fruits. You would say 4 oranges and 3 apples because they are different objects. You cannot add them together. That's the same thing in algebra. When the letters or the powers of the letter are different, that means they are different objects. So we cannot add them or subtract them together. They should be exactly the same. They should be like terms. So let's say here, if I eat one of the apples, or if I give away one of the apples, okay, you just subtract the 1 from the apples, not from the oranges. So you would say I still have 4 oranges, but because one of the apples has been given away, so I'm left with 2 apples, right? Or if I take away 2 oranges, you would say I'm left with 2 oranges and 3 apples, right? You subtract oranges from oranges, not oranges from apples, right? Because they are different objects. So let's do a few examples. 13x plus 6x. So you can see the variables are the same, the exponents are the same. So I simply add the coefficients, the numbers in front. 13 plus 6 is 19. Another example would be 2x minus 6x. So here I'm doing subtraction. The letters and the exponents are the same. So I basically subtract the 2 coefficients. So that would be 2 minus 6, which is negative 4. The third one would be 7y plus 6x minus 3y plus 12x. So here I have oranges and apples, right? Oranges should be added with oranges. Apples should be added with apples. So here I do apples with green, okay? And I do oranges with orange. So here 7 minus 3y, it's 4y. 6 plus 12, it's 18x's. Let's talk about another important property, which is called distributive property. When you have a number or a symbol or let's say a letter in front of a bracket, you distribute it to all the terms inside the bracket. So here, let's say I have 2 multiplied by 3x plus 2y. So 2 would be multiplied by the first term and then the second term. So here I write the letter and the coefficients will be multiplied by one another. 2 times 3 is 6. For the next term, 2 times 2 is 4 and the letter y. Okay, let's do another example. This is a more advanced one. Here I have a combination of apples, oranges, and then distributive property. So let's say here, first thing first, I have to simplify. So I'll use the distributive property and multiply 3 by y and then 3 by negative x. Okay, so it turns into 3y negative 3x. Then I have another 2x here and I have another 3y here. So again, the x's, all the x letters would be my apples, right? And all the y letters would be my oranges. Okay, I have 3 oranges. I gave away 3 oranges, so I'm left with 0 oranges, right? So 0 times y, 0y would be 0. And then I have 2 oranges, 2 apples. I gave away 3, so I'm left with negative 1. Another example, which is combination of distributive and apples and oranges, would be 4 times x, 4 times negative 5, which is 4 times x minus 20. Then here I have letter y in front of the bracket. So again, I use the distributive property that turns into yx plus y. Okay, and here 2 times x. The last step, I will have to simply add the apples and oranges. So here, this is apple, this is orange, but what about the other 2? Well, this could be a kiwi fruit and this could be a banana. Okay, I cannot simplify it any further. So going back here, let's say 4x and 2x are added together, 6x. But for the rest, they are 3 different fruits. So let's say this was orange, this was kiwi fruit, and this was a banana. Okay, so I cannot add them or simplify it any more further. Let's do another example. 6y plus 2 minus 4 over 5y plus y equals to what? So here, the coefficient here is 6, but here the coefficient is a fraction, which is absolutely okay. It doesn't matter if it's a whole number or a fraction or a radical, whatever. So it could be any real number. But remember, the y was an orange, right? So it's still orange, right? So what I do, I add all the oranges together. 6 and 1 is 7 minus 4 over 5, okay, which is 7 minus 4 over 5 times oranges, and then the 2, which could be, let's say, a banana, stays here. So in order to find this value, you have to do common denominator. So 35 minus 4 is 31y plus 2. Another example would be 3x plus 5 plus, let's see how many brackets, 1, 2, 3 brackets. I have 3 brackets here, but if you look closely, all of these brackets, they only have one variable. I only have green apples, right? Green apples. So I can simply ignore these brackets, curly brackets or parentheses, and then let's count the apples. So I have 3 here, 2 here, 5, but I gave away 1. It's 4 x's, right? And then let's count the constant. 5 and 7, 12. 12 plus 6 is 18. Okay, as simple as that. Let's do another one. So here again I have how many parentheses? 1, 2, 3. But here there is a number in front of my second parenthesis and another number in front of my third parenthesis. So first I have to simplify this thing and then find the value. So the first parenthesis, I just leave it here. I just put it here. I do not change it. But for the second one, the 3 would be multiplied by the two terms according to the distributive rule or law. Okay, so that would be 6 and minus 3x. It should be, sorry. So I made a mistake here. So that would be 6 minus 3x. Okay. So another thing here. So here it should be again distributive. So negative 2x and negative 2 times 1, which is negative 2. So here I have to see how many apples I have. So I have 2 here, but I gave away 2. And then I gave away another 3. So that would be negative 3x. And then the constant would be 10 plus 6, 16, minus 2, it's 14. Okay, so you can see it just, after a few examples, it would be a breeze. It's very simple. Let's do another example. Here, this one, it's a little bit different from the examples we did so far because we have letter x, but one of them, the exponent is 2, the other one is 1. Okay, although the letters are the same, but the exponents are different. So that means they are totally different things. They are totally different objects. So let's say if x is a green apple, okay, the x squared could be like donut. Okay, x squared could be donut. I know it's the same letter, but totally different things. So first thing, I add the donut. 6 minus 1 is 5. Then I add the apples. 1, 2, 12, 15. Then I add the constant. 6 and 7, 13. Okay, so I will reiterate myself because it's a very important point. Sometimes students confuse because it's the same letter. But in order to add or subtract, they should be like terms. And for like terms, we had two conditions. Not only the letter, but also the power or the exponents belonging to the letter should be exactly the same. So both of them should be x to the power 1. Or both of them should be x squared. Or both of them should be x cubed, right? So that we could add or subtract them together. Another example. Here, I have a combination of x squared, xy, and y, and x. Oh, and I also have x cubed, x squared, and another xy. So let's say here, again, I call my x's as apples, green apples. Let's see how many green apples I have. That's the only one. But let's say here, I have 2 oranges. No, 1 oranges here. Any other? No. So x squared, we decided to call them donuts. Okay, donuts. Another donuts here. So let's say here we have 2 more. So x cubed, let's just simply call them triangles. Okay, just a triangle. And then here we have another one, which is a combination of 2 symbols or 2 letters, xy. So xy, it's again a totally different thing. It doesn't mean apple orange. It could be let's say the sun. Yeah, let's call it the sun. So something totally different. Okay, let's call it the sun. So now let's add or subtract the like terms. So I start with cube, which is the triangle, so -3 of those. Then I start with the donuts. I had 1 here, 12 here, 13. So how many sun in the sky? 1 here, took away 5, -4. And then how many oranges? 1 orange. And then -2 apples. And then the constant, it's -6. So as you can see, it could be, a combination of many different objects. Let's continue this video by talking about multiplication, because in algebra we are talking about the variables and the operation between them. We talked about addition and subtraction. Now let's talk about multiplication. So here I have another video on exponent rules. You can also refer to that video. It gives more information about the rules. So let's start with the most simple rules. Here, let's say I have x to the power 2 multiply x cubed. Bases are the same. Both of them have got the same base, so I just write down the base, which is x, and here I add the exponents. So it turns out to 5. And y, okay, so it's common base. I write down the base and I add the exponent. But y, let me tell you, x to the power 2, it's x times x, right? X to the power 3, it's x times x times x, right? So this is what I did. I expanded. Now let's see how many x's I have. 1, 2, 3, 4, 5. So that would be x multiplied by itself how many times? 5. That's why here we add the exponents. We add the power. And let's do a couple examples. Y to the power 5 multiply y to the power 3. The answer is y to the power 8. Y to the power -2 times y to the power 8. We add them. 8 minus 2 is 6. Okay, so let me give you just a reminder. When the power is negative, comes with a negative sign, let's like here, okay? So x to the power -4, that means it's still x to the power 4 technically, right? It's technically x to the power 4, but then because it has a negative sign, that means it's flipped. So it would be 1 over x to the power 4. So this negative sign always flips, right? So here, y to the power -1, it's technically y to the power 1, but then it's flipped, okay? Now let's do more example, but here I included some negative exponent as well and some coefficients. So the first bracket, it's 5x cubed. The second bracket, it's 3 times x to the power -1. Here I multiply the constant together, so 5 times 3 is 15. And then here the bases are the same, so I write down the base, I add the exponent. 3 minus 1 is 2. Second example, 3x to the power 6 times -2x to the power -2. So here I simply multiply the two coefficients, which is -6, and for the letters, they are the same bases, so I just write down the base, but I add the two exponents, which is 6 plus -2, which added to 4. Another example, 4 times x times y. The first bracket multiply by 2x squared. So here once more, we multiply 4 by 2, which is 8. And then here we have combination of two letters. So I consider each letter separately, x and x squared. I write down the base, I add the exponents, 1 and 2 is 3. Here I have the base y, but the exponent, it's 1. I just write it as it is. The next one here, I have again a combination of two letters. So I start with the constant, negative 6 times 2, it's negative 12. So I consider each letter separately. So the x, but for the y, I have one here, I add it turns out to 2. Last operation we have to talk about is division, which is the opposite of multiplication. Let's do a few examples. Let's do by example. So here, again, you have to consider constant togethers and similar letters together. So let's say here I have a fraction. Fraction is the same as division. On the top, I have 12 x to the power 6, y to the power 3, z to the power 1. And on the denominator, I have 4x cubed y z squared. So as I just mentioned, I consider everything separately. So constant together, letter x together, letter y together, letter z together. So 12 over 4 is 3. X to the power 6 divided by x to the power 3. So you can just simplify them. Okay, so 6, that would be x to the power 3. And then y cubed over y squared. And then z over 2, it's 1 over z. So for this one, you can just say, this applies to all the rest, but this is the most simple one, so I just do it for you. So here, you simplify this with this, you end up with 1 over z. Okay? Or let me do this one for you as well. Y to the power 3 divided by y. So you simplify, you're left with y squared. Okay? Now let's do another example. These topics in algebra are very basic, but actually they are very important because in order to solve more advanced question, you should be very good at simplification. Otherwise, you will end up with really huge expressions. So again, I have a fraction, I have a combination of constant x, y, and z. And on the denominator, I have y and z. So I consider each one separately, constant together, x together, y together, z together. But if I'm missing any variable, I shouldn't put 0. Because if I put 0, that means the denominator is 0 and it's not possible. When something is missing, that means it is 1. Okay, so 32 over 2 is 16. X over 5. Y over y squared, y negative 1, and z to the power 5. Okay, so this is the final answer. I give you another example here, combination of constant x, y, and r. So again, I just try to separate and put everything separately. You don't have to do it like this, but I suggest you do it because it really helps, especially for the beginners. It really helps and it avoids making mistake. It avoids you to make mistakes. So 6 over 2 would be 3. Then x over x to the power negative 2. So this negative 2, when it comes to the top, right? So for this one, let me explain it a little bit more. So x over x to the power negative 2, I can either say x to the power 1 because it's a division. So that would be the exponent would be subtracted from one another. Unlike addition, which the exponents are added, for division, the exponents are subtracted. So x, 1 minus negative 2, it's 1 plus 2, so x to the power 3, okay? Or x to the power 3. So y minus 2. Again, the same thing happens, y to the power 1, right? And then here, negative 2, so that would be y to the power 3. Perfect. Now let's do let's talk about another important property, which is the exponents, when it's raised to the power. Last part of this video I would be talking about exponent. So x squared, okay, and the whole thing is raised to the power 3. So what it means is that x squared times x squared times x squared. And as you can remember, if the bases are the same, we just add the exponent. So that would be x to the power 6. Or simply, we can just say 2 times 3 is 6. Okay, another one, y to the power 5, the whole thing raised to the power 2. If I want to expand it, that would be 1, 2, 3, 4, because it's to the power 4. So that means y to the power 5, it times by itself 4 times. Then the bases are the same. We basically add the exponents. It turns out to y20, or we could simply say 5 times 4. Last example would be combination of constant or different two variables with different exponents. But remember, this power would be distributed to each of these equally. So 2 to the power 3, which is 8, x to the power 3, x cubed, and y to the power 2, the whole thing raised to the power 3, which would be y to the power 6. Let's continue this video with more examples. 3xy, the whole thing raised to the power 2, multiplied by another bracket, which inside the bracket it's 2zy, and then the whole thing is raised to the power 3. So what I usually do, I start with 1, simplify, and then go to the next, simplify, and then multiply the products together. So the first one, the power would be distributed, so that would be 9 x squared y squared, right? So for the second parenthesis, the 3, which is the power, would be distributed equally. So 8 z cubed y cubed. Now I have two parentheses. The constants are multiplied by one another, which is 72. Then I have 3 different variables, x squared, okay, and y2 from here, y cubed from here. So that means the y, and then the bases would be added, y5, and then z cubed. Next example would be a combination of what we learned so far. So it's a fraction. Finally, we're going to do a division, but on the numerator, there is a parenthesis raised to the power 2, and in the denominator, I have 2 variables. So I start by simplifying the numerator. So the power would be distributed, 49 x squared y squared z squared, and the denominator, the x cubed y squared. So remember, here go step by step. So 49 divided by the constant, which is 1, then x squared divided by x cubed, y squared, and then z squared divided by 1. And then if you simplify everything, you will end up with 49 x to the power -1 z square. Another example, which is again a combination of what we learned so far, and these are really good for your practice. You can find lots of these practice questions on the webs, just by searching. Try to do as much as you can. So in this here, in the denominator, we have a multiplication of 2 parentheses, and each one is raised to a different power. Then on the denominator, we also have combination of distributive property, and then also this power. So let's do one by one. So the first parenthesis would be, the power would be distributed, so 36 x to the power 4 y to the power 4. The next one would be 8 x cubed z cubed, and then in the denominator, here let's start with the parentheses again first, and then we distribute the 8. So 9 x squared y squared, and then in the next step we will distribute the 8. Okay, so this is what I did, 8 times 9 x squared y squared, and then on top I have 36 times by 8. Then x4 from the first parenthesis, x3 from the second, x7 y squared z cubed. Next step would be simplifying, and then I consider the constant together. So 36 times multiplied by 8 divided by 72, which is 8 times 9, turns out to be 4. Then x7 to the power 7 divided by x to the power 2, it would be x to the power 5. Y squared will be simplified with y squared, so I don't write it. Z to the power 3 would be simplified with nothing, because here the denominator would be 1, and it turns out to z cubed. I hope you enjoyed this video and it helps you in learning algebra faster. Please don't forget to subscribe to my videos and follow me for more videos.